Gas pressure is demonstrated by heating a liquid in a sealed tin. Remember that pressure from a gas is caused by collisions between particles and the walls of the container. Now, this experiment can be dangerous and should not be done at home, but what we would do for the first step is pour a small amount of water into a tin and seal it with a close-fitting lid. So the container should be made of metal or another strong material, and we have a small amount of water at the bottom and then a sealed lid at the top. The gas particles inside the tin exert the same outward force as the inward force exerted by the particles outside the tin. So there is an outward pressure on the tin due to collisions from air molecules inside. There is also an inward pressure on the tin due to collisions from air molecules outside. But overall, we notice no effect from these pressures, as the pressures are equal and opposite. For step 3, we gently heat the water using a Bunsen burner. So the thermal energy is transferred from the Bunsen burner to the water and the air inside the container, which are therefore heated. The water will evaporate and release more gas particles into the tin. So the water reaches a boiling point and turns to steam, so we have air and water vapour inside the container. The gas particles move faster as their temperature increases. So the air molecules gain kinetic energy as energy is supplied by heat flow, so the particles move faster. Then in step 6, the outward pressure from the gas is now greater than the inward pressure. So the outward pressure has increased as there are more collisions and more force due to an increase in kinetic energy. This causes the lid of the tin to fly off. So this is a result of the outward force, as the lid is the weakest part of the tin. So as you can see, it's really important that you wear eye protection and keep a distance when observing this experiment.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!